Hello, I'm Ben Domicino and this is Weatherpulse. Today marks the 1-year anniversary of a tragic thunderstorm asthma event in Melbourne that resulted in 9 deaths and directly impacted the health of thousands of Victorians. There is still a lot that we don't know about thunderstorm asthma, mainly because it doesn't happen very often in Australia or around the world. Research suggests that 4 ingredients are needed for thunderstorm asthma events to occur and be widespread enough for its impacts to be defined as an epidemic. High concentrations of allergenic materials such as pollen, a thunderstorm capable of sweeping up this allergenic material and blowing it over a populated area, the formation of allergenic particles that are small enough to be breathed in, and the exposure of people who are sensitive to the airborne allergen. In Australia, epidemic thunderstorm asthma cases are known to have occurred in Wagga Wagga, Tamworth and Canberra, although the most frequent and severe events have taken place in Melbourne. Prior to 2016, there were 5 documented cases of epidemic thunderstorm asthma in Melbourne since 1980, all of which have occurred in November at the peak of central Victoria's grass pollen season. Last year's event in Melbourne is thought to have been unprecedented in scale and severity when compared to all of the other documented cases, both here in Australia and the rest of the world. So, what is it that made the 2016 epidemic thunderstorm asthma event in Melbourne affect so many people? Well, experts think that it was simply the right mix of ingredients. Rainfall during the lead up to November 2016 was prolific. Victoria experienced its 10th wettest spring on record, including its 2nd wettest September in more than a century and a wetter than average October. This early season rain boosted vegetation growth across central and western parts of Victoria, which then dried out as rainfall tapered off during November. On Monday the 21st of November 2016, a broad band of thunderstorms swept across western Victoria and reached Melbourne early in the evening. While the storms weakened before reaching the city, a burst of dry air rushing out ahead of the storms, called a gust front, swept across Melbourne carrying airborne pollen fragments that were small enough for people to breathe in. Another important feature is that Melbourne's population is situated to the south of a large area of grassland that has been converted from bush habitat to pasture. The time of day also meant that lots of people were outside, which is thought to have further exacerbated this event. So while we're still trying to figure out exactly how these events occur, one question that's worth asking is, will we continue to see these epidemic thunderstorm asthma events in the future? It's not yet possible to know when, where, and how frequently epidemic thunderstorm asthma events will happen in the future. However, we can look at how some of the ingredients required to produce these events may change in the years ahead. This graph shows Melbourne's observed average maximum temperatures during spring since the early 1900s. According to the CSIRO, Melbourne's average maximum temperature during spring is expected to fall somewhere within the yellow shaded area of this graph if we continue to emit greenhouse gases at the current rate. The blue pathway is where Melbourne's average spring maximum temperature is expected to track if emissions are reduced to the goals set out in the Paris Agreement. Research has shown that an increase in maximum temperatures may cause intense thunderstorms to become more frequent in Melbourne by the end of this century. Warmer air near the ground may cause more energy for storm development. In addition to temperatures, rising levels of carbon dioxide in the atmosphere are likely to enhance pollen production in grass species around the world. This graph, produced by Climate Central in America, shows that the production of grass pollen could rise by 200% if the concentration of carbon dioxide in our atmosphere is doubled. More research needs to be done before we can figure out exactly how the complex processes involved in epidemic thunderstorm asthma are going to change in the future. However, increasing the temperature and concentration of carbon dioxide in our atmosphere may make these events more likely in the years ahead. In response to last year's event, a new epidemic thunderstorm asthma forecast system is available in Victoria this season. The warning system predicts the likelihood of a thunderstorm producing an epidemic thunderstorm asthma event. You can access the forecasts and find more information on thunderstorm asthma by visiting the Vic Emergency website or downloading their mobile app now. And that's all for today's Weather Pulse. If you have any questions about the weather around you or any feedback, you can send it through to weatherpulse@weatherzone.com.au. Remember, if it's happening in weather, you'll find it here on Weather Pulse.